Let's look at shapes today. Remember, simple has a particular meaning. Closed, again, closed has a special meaning. Made of only line segments are called polygons. So they should be simple, which means they should not cross each other, or rather, the curve in case of a polygon should not cross itself. They should be closed. That means they should have an interior and exterior areas with a clear-cut boundary. Remember, they are made up of line segments. That means AB is a line segment, BC is a line segment, AC is a line segment. This is a closed figure and it is a simple figure. Similarly, line segment, line segment, line segment, line segment. So again, if you notice, we give proper names using capital letters to these endpoints of the line segments. And usually we give the names in a sequence. So we start from one side, we move anti-clockwise. So A, B, C, A, B, C, D. We don't give these names randomly. That means we don't give something like A, C, B, D. Now, where the line segments meet is called vertex. So, AB is a line segment, BC is a line segment, CD and AD. So, these are the line segments. A, B, C, D. These are the vertices, the plural. Two sides with common endpoint are called adjacent sides. So here AB and BC. So here itself you can make out because B is common to both. So B is the endpoint. So these are adjacent sides. Similarly, BC and CD. So adjacent sides, vertices, and the line segments themselves are called sides. Endpoints of the same side of a polygon are called adjacent vertices. So A and B are adjacent vertices. Similarly, B and C, and so on. When we connect the vertices of a polygon which are not adjacent, they are called diagonals. So A, B, C, D. So if we connect these two, this line and similarly this line, they are called diagonals. Okay, let's look at some types of polygons. Triangles. A three-sided, tri means three. A three-sided polygon is called a triangle. Now this is a polygon with least number of sides, and usually if we have this as a triangle A, B, C, and remember we have named the vertices. Now if we want to name the sides, remember we can always refer to them as A, B, B, C, C, A. But if we want to give single letter names to these line segments, remember they can be given lowercase letters. And usually, as a common practice, the names are given such a way that the lowercase letter of the corresponding capital letter is opposite to each other. So A is here, capital A is the name of this vertex. So the opposite side is given A, which is in small letters. Similarly, B, B, C, C. Based on the length of the sides, we can categorize these triangles into three types. These triangles into three types. If A is equal to B is equal to C, that is, the length of the sides is equal, then we say it's a equi means equal, equilateral triangle. If A equal to B and not equal to C, that means two sides are equal and the third side is unequal, then we say isosceles. Now we don't have to write triangle completely every time. We can just say, use the symbol of the triangle. When A is not equal to B is not equal to C, that means all the three sides are unequal, then we say it is a scalene triangle. So equilateral triangle, isosceles triangle and scalene triangle. Okay, if you look at this triangle, you can immediately see that this has three sides and three vertices. Okay, let's look at the next type of polygon, that is quadrilateral polygon. Quad means four, so it is a four-sided polygon. So it has four sides. Let me draw that. A, B, C, D. So four sides, four vertices. Now in this case, there is something called as opposite sides. There is another property with respect to these line segments with common vertex that are very important. Say for example, you have a point from which you have two line segments, right? Line segments, okay. Let's not make it as a ray. Now this is called an angle. So an angle is formed when there is or when there are two line segments with a common endpoint. So here if you look at the triangle, how many angles are there? You have an angle here, you have an angle here, you have an angle here. So you have three angles. Similarly, here you have an angle here, you have an angle here, here and here. So it has four angles. So just like you have opposite sides and adjacent sides, you have adjacent angles and opposite angles. Now let's say this is A, B, C. We refer to this angle, or you can say angle is nothing but the gap between two line segments with common endpoint. Now we will later on look at how to measure this angle. Okay, but for the moment let's keep it simple. Okay, so we have seen quadrilaterals. Are there any more? Yes. Remember, triangle had three sides, quadrilateral had four sides. So naturally there will be polygons with five sides. Pentagon, so five sides, four, again A, B, C, D, E. By the way, this doesn't look like a straight line, but it should be a straight line. Hexagon, so again six. So A, this should be a closed figure. Remember, A, B, C, D, E, F. Similarly, heptagon, 7, octagon, and so on. Now remember, polygons are made up of line segments. Let's look at a circle. Now, a simple closed curve which is not a polygon. Now take a point and maintaining an equal distance, you form you mark points which are equal distances from this point. Now if you connect these, what you get is called a circle. So this point to any point on the boundary is called a radius, and this radius is constant. That means it doesn't change for a circle. So a radius is a line segment which connects the center to a point on the boundary. So this is given a name O usually, and this we can give any alphabet, say P. So O is the center and P is said to be the point on the circle of the circle. Okay, so let's say we have a circle, we have a point, this is the radius. Now if we extend this to the opposite end, we get what is called as diameter. So a line segment connecting two points on the circle while passing through the center is called the diameter. So which means the diameter is equal to, from here to here it is one radius, and from here to here it is another radius. So diameter is equal to 2 times radius. A line segment connecting 2 points on the circle is called a chord. Okay, now think of it like this. You have a circle, right? Is the center. Now this is a line segment connecting 2 points on the circle. So this is a chord. Okay, let me write it separately. So AB is a chord. Similarly, CD is a chord. What about this again? EF is a chord. Is a chord with a special name, of diameter. Okay, let's look at another circle. Now let's take only a part of the circle, only this part. Let's say A and B, and we show it like this. This is called an arc. It is a portion of the circle. So which means if we say AB is an arc, that means the other part is also an arc. But how do we refer to that? Because AB. So put another point here. Let's say C, right? And put another point here. So now we can say ADB is one arc. So correspondingly, the other arc of the circle is ACB. There is something called as a sector. If you connect this arc, endpoints of the arc to the center, that region is called the sector. So a region in the interior of the circle enclosed by an arc on one side and a pair of radius, or since we are talking of plural, we should say pair of radii on the other two sides is called a sector. So a region in the interior of the circle enclosed by an arc and a pair of radii is called a segment. Now segment of a circle. So again a circle, and now this time a chord. So this is a segment. Now naturally, if this is a segment, this is also, the other part is also a segment. A region in the interior of a circle enclosed by a chord and an arc is called a segment. And we can say that this is a major segment, this part. See, the moment you define a segment of a circle, there will be automatically another segment. So this is, we can say, major segment because it is bigger, and this is the minor segment. Okay. Another very interesting, the length of the boundary is called the circumference of the circle, or in other words, the distance around the circle is called circumference. So in one circle, let's look at all of them. So this is the center, this is the radius, let's say R, O, let's say A, let's say B, C, let's say D, let's say E. Now O is the center, OA is the radius. Let's put a point here and name it. Let's put a point here and name it AB. This is an arc. DFE is a segment. AOB is a sector. DE is a chord. GA is a diameter. So that is a circle. The circle is very, very important. I'm sure if you look around, you will find lots and lots of circles. Okay, I think enough for today. Bye for now.